Hi folks, I'm Mike Madeja, Director of Education at the Independent Seaport Museum. I'm delighted to be here at the U.S. Army Corps of Engineers on board a survey vessel with Steve Farrell, the Chief of Surveys with the Army Corps. Hi Steve, how you doing?
Good, Mike, how are you?
Awesome, great. Thank you so much for having us on board today. So what are we on top of?
We are on top of the Survey Vessel Cherneski. It's a hydrographic survey vessel. One of the vessels we use for doing hydrographic surveys along the Delaware River, C&D Canal, Chesapeake Bay, and Delaware Bay.
So you said hydrographic. What does that mean?
So hydrographic surveys involve the measurement of the bottom surface of the federally authorized navigation channels. So for a ship to get from the ocean to Trenton, they travel through federally authorized navigation channels at different depths, and we maintain those by conducting hydrographic surveys of those channels on a periodic basis. Those are exam surveys. And when we identify areas that are shoaled in that need to be dredged, we conduct before dredging surveys, immediately before dredging operations occur, and after dredging surveys, immediately when completed. That ensures that the channel has been cleared per the project plans and specifications, and it also is used as a basis for measurement for payment.
And shoaling is a cool concept with dredging and what the Army Corps does too, because I think people see a highway, they think it's pretty static, not much is changing with it unless there's a big project, but shoaling happens continuously over time. So could you tell us what shoaling is?
So shoaling is sediment that is carried down the river, comes from upstream, and where the river currents slow, that sediment settles out and piles up on the bottom.
So do we get to see how some of those maps are made, or do we get to see any maps today?
We can show you some stuff on the computer.
Awesome.
If we get underway here, I'll show you how some of that happens.
Cool. Compared to something vast and large like a dredge too, this looks like a lot smaller of a cabin for crew to be working in. Typically, how many crew members are on a survey vessel?
Typically 2 crew members. We have a survey technician and a vessel operator. The survey technician is responsible for the sonar, the positioning equipment, taking measurements throughout the day, sound velocity casts, which we'll show you, and the vessel operator is responsible to interact with other vessel traffic, make passing arrangements, and make sure the boat's being navigated safely and to the area.
All right, so Chris, what are you working on today?
So we're going to go down to Marcus Hook. They're dredging down there, see what they're up to. Our responsibility is to get a survey before they start dredging, so they have an idea of what material is there. And then after they dredge, we take another survey to see what they actually remove. So now with multi-beam, you get 100% coverage, so you know everything that's down there and get an idea of what's really going on.
And when you say beam, is that being put out by the sonar or?
Yeah, so single beam is just one beam going straight down. This system has 256 beams that it shoots at one time. So you can change the swath width of it and everything. We build all of the lines, so we make plan line files for the operator to follow. This is the stationing, so the build line file is based off of that because it's very exact. So you see that yellow line that just came up, and there's some areas where, so that yellow line out here, that's the anchorage. So that's also maintained by us. And what we're measuring is actually time. So we measure the time from when the ping gets sent down and when it gets hit back. Knowing that time, you can calculate the distance. So we have our vessel here. You can see we're headed down Delaware River. Over here is the real-time cloud. So it will store a certain amount of information on there, so you can look at it real time and get an idea of what's going on. You can rotate this and everything. And
so have you ever needed to go out and find objects?
Yeah, so just last Friday, that truck that went off the... we found that.
Yeah, so there's even this hyper-local involvement of the Corps in these ways that I don't think people would connect. They see that news story and then they're just, I guess, it got removed. But y'all had to go out and find that.
The accuracy of our surveys is really critical for payment as well as for shipping.
And all that work that you see out there are those pipes that are connected to each other that are sucking in the material and pumping it.
Yes, it's sucking in material where we saw that piece going down at an angle off the front of the dredge, and it's pumping it out the back through this floating pipeline, and then this pipeline gets submerged down onto the bottom and goes across to our placement area. So it depends on the material the density of the material, and how fast it's moving through the pipeline, and how far up. We have to pump it up 50 feet over, helping to get over the outside berm, which you'll see when you tour our dredge material placement facility. So all those factors go into how far where the dredging area is relative to the placement area. And our team consists of everyone from admin folks to data processors to cartographic technicians, the guys out here operating the boat, operating the survey systems. I think this picture here really tells the story because that's a deep draft, large oil tanker in the background of a dredge that's maintaining the waterway where they need to transit to get from here to wherever they're going and wherever they're coming from. So important to be as accurate as we can possibly make it. So that's where Chris is doing a velocity cast he was telling you about. So this unit has a calibrated plate. So that's a small sonar right there. It sends sound down to that plate, measures the time it takes to get back. As Chris was saying, this is about time. They measure the time it takes for the sound to get from one place to the other. This measures the depth it's at and the speed of sound that's actually in the water column, counts for thermoclines, salinity, and different characteristics of the entire water column. So the calibration of our equipment is critical. So that's an initial calibration we do at the beginning and then during each survey. He could show you inside when he pulls that data in what the actual sound velocity profile looks like.
More data!
With the software, it just automatically does it. You just come in to the corrections, sound velocity, import, and I have it automatically exported to the sound velocity folder. It usually does two, upcast and downcast with the one. You can see how it bends. So it collects it in meters, so you can convert to feet, graph it again. See, that's a pretty good profile. Update the position, and this gives you the average. So I usually record that.
The sound velocity at the head is critical for the calibration of the system, for the initial forming of the sonar beam. So that has to be monitored constantly throughout the day. And as Chris was saying, when that doesn't match what he just recorded with the manual sound velocity profile, by 10 feet per second, we set a threshold, it throws an alarm. He'll know that the water's changing, the temperature of the water may change, especially when we work down in areas such as near Salem Nuclear or the entrance of the C&D Canal. As the tide changes and the current starts ebbing and much warmer patch of water comes out, we have to take multiple sound velocity casts to make sure we're accounting for all that.
All right, so we're officially back on land after going on the survey vessel. We'll look forward to seeing you next time, where we might get to see some remnants of dredging and what dredging actually looks like on land. So be sure to check us out again, and thanks to the U.S. Army Corps of Engineers for joining us today. More to come.